Okay, we're live, and we should probably check audio real quick.
Yeah, I guess just keep talking and I'll
Talk.
check it.
Talk.
I'll check it.
Okay, I heard it. It seems fine.
Okay, great.
So, building Wanix from scratch. We're almost done. Tara was sick. Now she is less sick.
Indeed.
And I guess it'll be a short stream today. Yeah, I did do a stream on Monday without you. I don't remember getting a whole lot done though.
Well, of course not, because I wasn't there.
Yeah, it's like somehow you help out a lot. Okay, so let me switch to this. I do have some notes. I think I went over this stuff on Monday, but you weren't here, so I'll kind of review. Got Go compiled to WASI running in it. That Go could have a 9p server, made sure that that works. That way a Go program can expose a file system to Wanix. While working on this, I made it so you could drag and drop files onto the terminal. Bloop, like that, and it'll write it to OPFS. So it's kind of a convenient way to get files in to Wanix.
Oh yeah, nice. Did we do that last week?
I think maybe I had started it. A lot of this stuff had started. We did the WASI shim had to be completed because it was kind of just a hack before. And then, like I said, we got this now a cleaned up version of this functionality, but the idea was I can make a Go program. It could expose a 9p server, but there's no networking. So instead it opens this file and then treats that file like a connection to the 9p server. And then by opening this file, it makes another file that you can connect to that will be the 9p server, so you can see what's being served by the binary. And so the idea was that's how we could do VS Code, where we could take the static files for VS Code, embed them in a WASI binary. So when you run it, it can do things, but it can also serve those static files to Wanix in a way that you can access them via an iframe. And I have been working on that since Monday. I kind of have VS Code working. Let's see, this is the debug. Actually, will this even work? Okay, we just have like logs. I can VS Code assets, instead of packaging it up as WASI, we can at least mount it with the PickRFS. Although I'll point out, I also did just last night rename /fsys to cap for capability and proc
yes,
to task.
I remember.
Yeah, that was one of the last things. I got some feedback from some other people, and I figure I'll just try it out. So this is what the Wanix root looks like now. What was I gonna do? Oh, try and mount VS Code. So capability new picker FS. And then we need to mount and then I can pick let's see, assets. Yeah, assets. So now at cap1 mount, we have the VS Code files and we can access those over the service worker. So if we were to make an iframe, it would be web DOM new iframe. Whoops. That's kind of relative. And then add that. So there's an iframe down there now. And then we can set its source, I guess, to /service worker. Cap1 mount. Attributes. Look at that. It's tiny, but that's VS Code loaded down there. There are some
that's
little
pretty cool to
errors that have to do with like static files not working, but and if we could do like with height something crazy like that. Web DOM style. See, you just made the iframe sort of full screen, and it's VS Code.
Yeah,
the things that aren't loading
cool.
are these static files. I don't entirely know why, but everything else seems to work. So
It just says error failed.
yeah.
So you can't get any more information about that?
Well, other than, I mean, I guess what I would try to do to investigate this would probably be to make these requests myself with fetch and see what happens. It's weird that they're all, it's like everything loaded, most of this is for VS Code, but then once it gets to these like PNGs, which is like, why PNGs? I wonder if it's and these are, wait, where are these coming from? These are remote. VS Code calls out to a CDN to load some resources. I don't know what these are, but I don't think we care about them.
And those say canceled, they don't say 404.
Yeah, but these ones should be working, so so that's kind of the next step with VS Code. But the other problem is, and this is mounting VS Code, but we don't want to mount VS Code. We want to build a binary that that serves it. Like there's one now. Well, I'll show the source first. The idea is we've got this assets directory with the static files that VS Code needs, and we can just embed those in this executable and then literally export those assets because it's a file system. What this does is turns the file system into a 9p server. We have a new type of, there's pickerfs and then there's loopback built in. So loopback capability is a capability that you make that just kind of like lets you connect to it, lets you connect both ends. So once you create this, there is a capability with a loopback file, and then I open that loopback file and serve the 9p stuff. And when I open that file, it creates a /mount on that capability that would then access this 9p server. So it'd actually be the directory contents that are in there. And that all works mostly, though there are some, actually, I guess it doesn't work right now because if we run VS Code, so this is that program. Exporting file system. Oh, and I guess what we're seeing over here is because of the fact that the way running these binaries works is we run that wexec and it's kind of polling the file that has all the standard out stuff that it would read. So that's why we're just seeing a lot of stuff over here. I might turn those logs off, but I didn't see. Oh, this might be hard with all these logs. Actually, yeah, I'll turn these logs off. That was here. So in theory, that VS Code program could do other things. So it can export the file system. And then what I was doing here was just some code to sort of be like, oh, we could make that iframe. We could, you know, set some CSS to make it full screen. And then point the iframe to, you know, wherever these files have been exported. And so running .vs Code would then make VS Code pop up. Okay, it's probably not going to work. So this is the client. I guess it's not. So if we look at this capability 1, this is where it was connecting to loopback, and when it connects, that file disappears, and then another directory opens up, which would be mount, and then that would be the contents of whatever it's serving. But you can see it. It's speaking 9p, and it's only able to send in 9p. The first message you send is the version. So, oh, I wonder if this has to do with tags.
Tags.
The 9p protocol includes tags as a way to sort of like say, here's a request ID, so that when you send back a reply, it can be like, here's the reply for this request ID. And if you're just doing them synchronously in order, then it doesn't have to do more than one at once. So it would normally just have a 0 tag. And that's when it usually works. And I noticed in another situation, it broke when it got to tag 1. So that might be part of what's going on here. But anyway, last time I did this, I also got another error saying async IO was not working, which is let's see, an interesting thing to explain.
But that's not happening now?
No, I think it's because I commented this stuff out. It seems to it might also be a race condition because I think it's worked when I've commented this out. Worked as in shown the error. Maybe if I do it again. But async IO, that's allowing programs normally when they do like a read or a write or anything to do with the file system, it could potentially block. It's just like I want to read some data, and it could block indefinitely because it's going to wait until the other end sends something. But in the meantime, the program normally won't be able to do anything else. Go is designed for that kind of concurrency, and so you can have other things going on while it's blocking on some IO. But in order to do that, it uses a feature of the operating system that lets you check to see if there have been changes. So you do a read and it blocks, and if you're a concurrent language like Go, you could say, okay, it's blocking, I'll go and do other stuff. And I'll just have this thing that I can pull that tells me, oh, there's stuff for that file. Now go back to that read. So that's async IO, and WASI defines how you implement that. By default, the WASI shim that I was using was not didn't support it. So this is their pull implementation. So I was getting this error, async IO not supported. This might also improve the performance of some stuff that I've been testing. But so it'd be cool to figure this out. I did see back when this container to WASM where I got a bunch of tricks, they actually implemented something. They implemented that function, and then they referenced this GitHub issue where they've been talking about it ever since, which was originally back in 2023. And this is still open. And however, a couple people have suggested some ways to implement it. I don't know how it works. I don't know this ABI. I don't know technically what it's supposed to be doing. Reading this, I don't get a good sense of what it's doing without kind of thinking through it. But it didn't seem to depend on anything else, so I just kind of tried it out, pasted it in, and actually, I think that's why we're not getting the error, because because I think I applied that patch. Yeah, but it doesn't seem to be working or something. So anyway, that's one dead end for VS Code, because async IO seems to be getting in the way of being able to run that program and have it serve 9p files and then do other stuff. Obviously, I've wanted to get VS Code running in Wanix for a while, so it's kind of nice to be this close. And, Apptron and stuff. So I don't know. I got to figure that out. The other big thing for this release, which maybe these don't need to be done for the preview release, but getting the Go compiler to run in Wanix, specifically a WASI built one.
Do you have like for the 03 release? Do you have like users should be able to do like some specific thing?
I mean, I have a story. There is sort of like, it's like a demo script. I don't know a specific. I mean, ideally it would be like, okay, now here's VS Code, and then here's a compiler, and then, now we can edit the source for this program for Wanix inside Wanix, and then we can recompile it, and then it, so just using that self-editing bootstrap loop is as a way to validate the capability and functionality of the system, even though that's not like something, why would anybody use Wanix just to edit Wanix? So there isn't like a specific user story. I mean, there's a bunch, so I don't know if we should.
Well,
we can set those up for the release. What I wanted the preview to be was like, here's an alpha version, so that you can play around and give feedback and maybe help out fix, some of these issues that we want to fix before 03. So it's definitely an incomplete kind of alpha release, which is why I could probably do it without these, but why do you ask?
Well, I mean, that could help you determine whether those things need to be included, but it sounds like the preview's a little bit more
kind of loose.
Open-ended.
I mostly just want to be able to tell a story or give, a draft version of a demo that has all of this stuff.
Well, I would say giving it to people to play with, it would be good to still give them some intro set of steps to take to get started using it. So just making sure that they can do like all of that.
Yeah, and I've started revisiting the wiki, or the README. Kind of took out all the old stuff that had to do with using it before, and thinking about, here's some steps that you can do to get it running and to get it to do something interesting. And then once you've completed that, you're in a place to explore, I guess, if you wanted. So I think that's part of the README for this release.
Cool.
But the Go compiler, and I like it because the Go compiler sort of closes the loop. Wanix was inspired by getting the Go compiler to compile the WASM, seeing that it could do that,
Mm-hmm.
and then kind of building everything around that. So now having everything else done, the compiler is sort of like a little keystone. And it's nice because it's actually doing a bunch of stuff. So it's really kind of putting the file systems stuff through their paces. Like it runs, I can show. Oh, it is here. Okay. So this is the Go binary. I could run it as is. And it's like, oh, it outputs, stuff. It works. But of course, it's not doing anything. If you want to do even version, you have to make sure that there's some environment stuff set up to something valid. I'm not sure what it needs for version to work. Okay, just go root. Then there is environment that shows the values for all those kinds of things, which it doesn't have a current directory. So I was able to go in here and kind of set these to all reasonable things. And I just put that in this go build script. So this will run go wasm build with this main.go that's in here, which is just a hello world, but it sets all of these path things, which, maybe it's possible to get Go to build with these as defaults instead, but for now, this gets it to run. The other problem, though, is the Go compiler does need a bunch of other files, like source files for Go itself, and a place to keep built packages, like for the standard library. And I was trying to get like VS Code kind of ship that data in through the binary, but it wasn't working at the time. So instead, I've just been mounting a Go root in. So go mount starts pickrfs, and then I pick the Go root, and then it sets it up, binds it to opfs/go. I think we could do that. Although I'll have to go back and find local Go. Okay, this is a Go root. Yeah. So now those files are here in a directory called Go, which is the Go root, and so that's what this was set to. So now we could run Go build, and I guess I turned off logging, but you would be able to see all of the file operations it's doing. It's just going very, very slow. It's doing a ton of stuff, and it would run for like 20 minutes before an error happens. And so part of it was optimizing OPFS. Since it's reading, well, actually, it's also reading from this pickrfs, which is the same file system API, but it seems kind of slow. And so I've had to do some things to try and make it faster. But I think that async IO might also be making it slow. And then eventually it runs out of memory, I think. And I don't know exactly why it's holding so much in memory. So a lot of interesting stuff. It sort of builds but doesn't finish, and there's more sort of like exploratory work to get that. So for example, we could, since we're reading like these Go root files quite a bit and OPFS is slow, we could create an in-memory file system, tempfs, and then copy these files into there, which I think I ran into a problem then with tempfs. So basically, like actually using these file systems to do real things, you start running into like, oh, here's a bug. Oh, you didn't implement this. And oh, this is slow. And so that's just like a slow iterative process. It's kind of boring, but maybe after I fix a couple more things, Go build will finish and it will have produced a binary that can run in this environment. Which even if it's slow, at least it works, and then we can figure out how to optimize. But so that's the Go compiler. So I don't know if that will be done in time, but at least it's close. As an alternative, I could try and get the old Wanix executable format, which was not WASI. It doesn't have the same constraints as WASI, and it worked before. So it's just very specific. It's like, it's for Go only. It's not a standard, but at least we got it to work. So that's one thing I could try and do, maybe not for the preview release, but at some point, so that we can, it'd be fun to say, even if it's useless now, run the old Wanix shell or the old compiler that did work and was faster. So I don't know about this. This might be, I think this is an after. But, and then the last thing that's in the way, we renamed those little file services. And part of that was so that they could coexist with the Linux root. So we don't have to be in this Wanix directory, because that adds some complexity, because sometimes you have Wanix in the name if you're on Linux, but outside of Linux you don't. So that would just make things more consistent. And this root file system that for this Linux is sort of built with, we have a system here for building the Linux kernel and setting up the Linux VM stuff, but you can see we're just setting up a bunch of directories and then copying the files in that we need. BusyBox and init, and what's in bin. These are all symlinks to BusyBox. Because BusyBox is a single binary that implements all of these, but it's a single file. So the way it works is you can create symlinks with the name of the program that you want it to embed, little applet like wget. And what BusyBox does is when you run a program as a symlink, it's going to run this instead, but its arg0, when it looks at its arguments, will be the name that you use to run it. So BusyBox can have code that looks at arg0 to say, what are you trying to run? Wget, which, who, and then just switches between them. So that's how BusyBox is one binary, but it has all of these programs in it, and then they're just symlinked here so that you can sort of pretend that they're real. But anyway, there's BusyBox and wexec, which was the tool that we made. I think that's all that's really in here. Anyway, the idea was, in order to get the Wanix file system to be at the same level as this one, this file system has to be served by Wanix. So instead of building this initram fs, that we tell the emulator to load with. Instead, we can tell Linux to connect over 9p to get the root file system. And that's kind of tricky because if that stuff doesn't work, then you don't even have a usable system. Whereas when I was setting this up originally with the Wanix mount here, while that wasn't working, I would have a working Linux system that I could get into here like this. But now, if it's not working, I can't even use it. So, for example, so if we don't give it the init ramfs, and then we tell the kernel to use 9p for the root file system, and then run this with console equals true, which is the sort of console display of the emulator that shows like the BIOS booting and stuff. Before this, we can kind of see what's happening. Oh, so it took me a while just to get it to do anything that worked at all. So the fact that it's like,
it's not ahead.
It didn't panic. Instead, it's some other error. But this is where I was saying, like, ID1 might be that tag thing. Because when I watch the logs for this, it seems to work until it gets to a message with a tag of 1. And that might be what request ID1 is referring to. So it might be that I'm not implementing how tags work in the protocol, or I'm doing something wrong, and that's causing this. And so maybe if I fix that, then this will work.
How do you check whether that's the case?
I don't know.
What would you do? Would you just try to fix it then if you don't know how to?
Kinda.
I mean,
if I turn on logging, I can see that. Let's see, which logging is this? This is the one that I turned off. So you can kind of see the messages of the protocol. It sends a version, gets a reply, says to attach, get attributes, right? We get the reply, and the T is transmit and reply. So it seems to work, and it does a bunch of stuff. It opens files, it reads stuff. You can see it's reading BusyBox, so it's like doing cool stuff, but then we get this error, and the only difference I can tell, well, the tag is 0 for all of these, and then once we get to these ones, even though there are responses to them, this is, when it stops and when it complains. So that's the only hint. And also the fact I was talking to a friend who is doing some stuff with the VD6's 9P, and they were also dealing with tags. I thought I had implemented it in a way that worked. So I might be able to talk to them and learn that I did it wrong and fix it, and then maybe that resolves the issue. But I have nothing else to go by, because there's really not, giving this to Claude or whatever doesn't give me much.
Yeah.
And this is the kernel, and like nothing happens before this. So, it's possible you can get the kernel to spit out more debug stuff. but I have a feeling that it's related to this tag thing. I mean,
feelings are not nothing.
so hopefully that's the thing. But I have to work through that. And so those are the 3 things that I'm now blocked on, or working on. And so I'll just kind of keep working on these. I mean, none of them are necessary for the preview release, but I'm just gonna keep going, I guess, maybe for another week while I also work on the README and like release notes and stuff. Also starting to create issues for everything that I know is broken.
Gotcha.
But I guess it feels good and weird to sort of be like, well, there's nothing else to do except fix these things. So
yeah, you can see the light at the end of the tunnel.
Yeah. Service, yep, we did those things. Yep. Look at all these old to-dos. Waiting to serve.
So
We did a lot of these. Oh no, some of these are... Okay. Kind of did that. And then these were notes when I was trying to get the Linux file system integration. Ugh, okay. So much work.
hopefully you've had a good time.
It's I don't know. It's taken longer than I wanted. But I'm pretty happy that it's mostly working and that it's, all coming together as imagined. And then after this, there are things that we can do to use this for Aptron and stuff. Joelle has some uses for it. There are a bunch of uses and examples and demos and things that we can do as blog posts or something. So then that's the other thing, is I also need to start writing about it. So I'll get TerraGen and start publishing on my blog about it all.
Yeah, that's exciting.
So that's it. I don't know how much actual work I want to do on the stream because it's all kind of boring.
Well, cool. I think this was useful. Like, definitely for people following, and maybe it will be useful for you to look back on.
Yeah, and to see this last mile stuff. But yeah, I guess I'm excited and anxious. Like, I just want to get this done, get it out.
Yeah. Yeah, it is exciting. You should feel accomplished. I know it's hard because it always seems like there's more to do, but still.
I feel it a little. Like, I'm very happy with the code base. It's nice and organized and simple. As simple as it can be.
Yeah.
Yeah. I wrote some new copy text around it. I've been calling it a virtual operating system kit because it's it's really just a bunch of primitives, and then by default we happen to use them to give you something that looks like a system that can run stuff. But really you can use this to build a lot of things. You can ignore half the stuff that it can do and still get value out of it, but we'll see if that's what people actually use it for. But I like this term virtual operating system. When you say operating system, there's an association with, if you're a technical systems hacker, you're thinking the hardware abstraction, like managing resources, managing memory, multiplexing devices and CPU and all the stuff related to the actual, interfacing with the actual hardware. Mm-hmm. Other people, less technical people, when they hear operating system, they think more like the UI, like Finder and Explorer, right? It's like more of what I would call the graphical shell of the operating system. Mm-hmm. But Wanix doesn't really have any of that because it's not running. It's effectively running in a VM or a the WebAssembly thing, or in a browser where all the hardware stuff has already been abstracted. So it doesn't really have to worry about that. And instead it focuses on the user abstractions like the file system and the POSIX process stuff. But even then, they're considered abstract or general. So I think virtual is kind of a good framing for this project. Anyway, I've been trying to write some stuff out here. Here's some example uses. You could use this to embed system software, development tools, all this weird stuff related to tool chains for programming and development. Like, those are complicated things. If you wanted to run them in the browser for building like an editor, a development environment, Apptron, whatever, you need to get those things to run in the browser. So this is sort of like the Apptron use case for us, but people could use it. You could build a library that just has the Go. Once the Go compiler works, you could turn the Go compiler into a JavaScript library. It happens to include Wanix, but then you have like the Go compiler as a library in JavaScript. I don't know. Maybe there's something interesting you can do. I could do interesting things with that, but all this Plan 9 stuff, like these things you can do where you can like use the audio from another system, or like, there's all these cool things that you can do with Plan 9, but nobody actually wants to use Plan 9 because it doesn't actually have browsers or anything. So having something that lets you play with the Plan 9 stuff, I think is a really cool and you could use this for foundation for, if you wanted to build a more fully featured operating system on top of this, you could, that runs in the browser, or is, the platform for some crazy app, that's more complicated than just a web app. It needs to run some weird CLI tools or whatever. Like, you could use this to, in theory, you could take things that you normally run on a server to self-host and run the entire system in the browser. So there's a lot of open source software that you could get that's like, oh, now you spin up a cloud server and install this, and maybe it just runs on that server, like it has a database and everything. And then you have a self-hosted whatever, Maybe it's a note taking app. Maybe it's a AI chat interface. I don't know, whatever open source thing that you can like self host. Almost all of those are candidates for potentially trying to get to run entirely in the browser using something like Wanix. And that's interesting because with a couple of tweaks to the architecture, you could basically turn these open source projects into local first things, and you don't have to pay for a cloud server. So I think as local first stuff gets more popular, this might be open up some cool stuff. But
Yeah.
I'm just proud of the design. It's so simple, elegant, and yet very capable.
Yeah. And it will mean it will be cool to see what people decide to do with it. Maybe stuff you couldn't guess.
Yeah, exactly. So that's why I want to get it out. And I'll work on these a little bit more, maybe until next week, and just see where it's at and just ship with wherever these are at.
Yeah. As long as people are feeling able to mess with it, then it seems like that's just wherever you want to call it.
Yeah. But that's about the hour.
Cool. I'm gonna go blow my nose and eat some lunch.
I am also going to get some lunch. I've been wondering how many days we're on day 15. I wonder how many days there will be when this is done, release. When can we end this series?
Wow. Well, I'm having fun, so we could keep going, but
We'll always have something, but I'll probably want to change modes to focus more on like writing and marketing stuff.
Mm-hmm.
And then it won't be as fun to stream.
Yeah. Fair enough.
Okay. Good stream. Thanks everybody.
Yeah. Okay. Bye-bye.
See ya.